So use first the theorem to show that this given integral is given by 2 pi a divided by a squared minus b squared raised power 3/2. So let's quickly go through the solution. So we have integral from 0 to 2 pi of the theta over a plus b cos theta squared. This can be written as integral from 0 to 2 pi of the theta over a plus b times e raised power I theta plus e raised power minus I theta divided by 2, and then we square. So this is just by substituting the corresponding value of theta in terms of the exponentials. Once we have done that, the next step will be to simplify by saying let e raised power I theta to be z, e raised power minus I theta is 1 over z. When you work out the theta, you get dz over iz. So we'll have the integral from 0 to 2 pi will be given by. Now, whenever you change into the new variable z, then we are working with now contour integration. So given by now 1 a plus 3/2 into z plus 1 over z, and then you square. So the theta, you put the z over I z. But then don't forget to explain that C is the unit circle. Must always specify which contour you are working on. So next step on simplification, we will get integral along C of minus 4 iz dz divided by a plus bz over 2, and then multiplying here we get b over 2z. So we are squaring this. And then we can actually write this as, instead of writing the dz at this point here, we have minus 4 iz, then dz over 2z squared. So that's how we can write this given integral here. So I hope you should be able to see that the reason that's why I'm putting here minus 4 iz is because when you write 2z squared, and then I have minus 4iz. Then if you simplify this one, you get minus 4iz over 4z squared. So this and this cancels out, and 1z and then 1z here. So saying negative I over z is the same thing as saying 1 over zi. So it's still the same expression. I'm just writing this one for easy simplification. So the next point, we'll write the integral as integral along C of minus 4iz dz over bz squared plus 2az and then plus b squared. So multiply this one by every term here, which will be given by so I hope you should be able to see that here we have LCM is 2z and then so 2za and then plus bz squared and then plus b and then square. So this 2z and this, because we'll be now squaring, so they'll have now 2za plus bz squared plus b. You square this and then you write 2z, you square this, and then so when you multiply by this 2z squared, is now what cancels out to remain with this term here. So that simplifies to negative 4i over b squared, factor out b squared, into, because remember everyone also, when I square this point, I'll have now b squared this term and also b squared in this term. So factoring out, I have integral along C, and then z dz over z squared plus 2az over b plus 1, and then square. So poles are obtained by putting the denominator equal to 0, i.e. our numerator will be given by z squared plus 2a over bz plus 1 squared is equal to 0. So which means, for this quadratic, you can write it as z minus alpha squared times z minus beta squared equals to 0, where when you solve this one, you get alpha is given by minus 2a over b plus square root of 4a squared over b squared minus 4. And then you divide this by 2, so which is the same as negative a plus square root of a squared minus b squared over b. Actually, it's not hard to solve this one by simply taking z squared plus 2a over bz plus 1 equals to 0, and then using quadratic formula. And then beta will be given by minus 2a over b minus square root 4a squared over b squared minus 4. So we divide this one by 2. So this will be negative a minus b minus a squared minus b squared. We divide this one by b. So there are two poles. So there are two poles at z equals to alpha and z equals to beta. Each of order 2. Now, since when I multiply the product of these two roots, I should get 1. So this is how the quadratic looks like. This is z squared plus 2 2a over b z plus 1. This gives me 0. So this product of the roots should give me this constant part. And then the sum of the two roots should give me negative of the coefficient of z. So I'll have, or saying alpha times beta is equals to 1 is only true if absolute value of alpha is less than 1, then absolute value of beta must be greater than 1. Then this tells us that there's only one pole. So alpha less than 1 of order 2 within the unit circle. So residue at the double pole z equals to alpha is given by limit as z approaches alpha d dz of z minus alpha squared minus 4iz divided by b squared into z minus alpha squared z minus beta squared. So which can be written as limit z approaches alpha d dz of minus 4iz divided by b squared into z minus beta squared, which is the same as minus 4i over b squared limit as z approaches alpha of z minus beta squared times 1 minus 2 into z minus beta, then times z, we divide this one by z minus beta or 4. We are simply using quotient tool to carry out this differentiation. So by doing that, you'll get minus 4i over b squared limit as z approaches alpha of z minus beta minus 2z divided by z minus beta cubed, which is the same as minus 4i b squared limit as z approaches alpha of minus z plus beta, we divide by z minus beta cubed. Now you'll get 4i over b squared alpha plus beta into alpha minus beta cubed, which is 4i over b squared times alpha plus beta into alpha plus beta squared minus 4 alpha beta raised power 3 over 2. Remember, we are using the relationship between the roots of a quadratic equation and the coefficients of a quadratic equation. So alpha minus beta can be written as alpha plus beta squared minus 4 alpha beta, then square root. So that's why I have this. So this will be 4i over b squared, then minus 2a over b minus 2a over b squared minus 4 times 1 raised power 3 over 2. So the sum of the two roots will give us negative of the coefficient of z, and then the product of the two roots will give us the constant term, which was 1. So when you simplify this, we get negative 8i over 4a squared minus 4b squared raised power 3 over 2, which is the same as negative ai over a squared minus b squared raised power 3 over 2. Hence, by reciprocal theorem, hence integral from 0 to 2 pi of d theta over a plus b cosine of theta raised power 2 is 2 pi I times negative ai over a squared minus b squared raised power 3 over 2. And when you work out this one, we should get 2 pi a divided by a squared minus b squared raised power 3 over 2. So this is the proof of that problem. Thank you.